All right, so this is your 3-2 Properties of Parallel Lines notes. Our learning objective is to, oh, that would be PowerPoint, definitely not. There's my highlighter. To prove theorems about parallel lines. So we are definitely doing theorems this time. So an extension from last week's information. And to use properties of parallel lines to find angle measures. So we are having relationships between parallel lines. Please highlight the essential understanding. Special angle pairs formed by parallel lines and a transversal are either congruent, supplementary, or both. So we're going to look at angles being congruent, which means that their angles are the same measure. We're going to be looking at them to be supplementary. What does supplementary mean, y'all? Yeah, they add up to 180. So keeping that, let's write that down so we have a reference. So supplementary is they add up to 180. Congruent means that they have the same measure. So make sure you guys write that down, because we're going to be using the heck out of those pieces of information during this section. Same measure. Same measure. All right, so our first postulate, same side interior angles, says that same side interior angles are, please highlight this, supplementary. So write this down. Same side interior angles are supplementary. Just write down what I highlighted. It's important to know you have to have a transversal that intersects two parallel lines. And I think we get the point of that. So let's see what that means. That means, so you guys write this down, angle 4, the measure of angle 4, plus the measure of angle 5 is equal to 180 degrees. And the measure of angle 3 plus the measure of angle 6 is also equal to 180 degrees. So 4 and 5, and 6 and 3. Same side interior. All right, so now identifying again, yay! Anytime we can identify, it's a good day. Identifying supplementary angles. The measure of angle 3, so right here, is 55 degrees, and I'm going to put that right on here. If you guys can fit it in, I know it's tiny. It's 55 degrees. Which angles are supplementary to angle 3? So angle 3 and all these other angles add up to 180. And then just remember, and please highlight this as well, a straight angle measures 180 degrees. So if it makes a straight line, it's 180. In addition to being an alternate or a same side interior. So to answer this question, angle 4 is supplementary. Angle 8, because it's same side interior, is supplementary. Angle 6, because he's a vertical angle to angle 8. Angle 6 and angle 8 are vertical, so they're same. Angle 2, because he's right next to angle 3, making a 180. And that's it. Okay, so now let's do this problem together. I'm going to extend this page so I can see, get some room to work. Okay. If you know the measure of one of the angles, can you always find the measure of all 8 angles when two parallel lines are cut by a transversal? Explain. So if I know that this angle 3 is 55 degrees, can I find the measure of all the other angles? Just using, what if I use vertical angles? So here's 3 and here's 1. If I know 3 is 55, can I find 1? Because vertical angles are congruent. So this is 55. And we know that same side interior has to be supplementary. I know angle 4 has to be supplementary. I know angle 2 has to be supplementary to angle 1, so that is also 125. 8 is 125, so 5 has to be 55. 5 and 6 are a linear pair, so they have to be supplementary, so 6 has to be 125. And 6 and 7 are supplementary, so 7 has to be 55. So the answer is yes. Using the vertical angles theorem, and the same side interior, hold on, I want to see if it's postulate. We can find all 8 angles. All right, some more theorems and a couple of proofs. All right, theorem 3-1, alternate interior angles theorem. So of course I'm going to start with 2 parallel lines and a transversal. That's given. So you don't have to write that down. But I do want you to write down alternate interior angles are congruent. And just to hammer this home, what does congruent mean again? Because it means same measure. Same measure. Same measure. Okay, so in this case, which ones are the alternate interiors? Looking at our picture. Angle 4 is congruent to angle 6. Oh, it's convenient that they're the same color on mine. On yours are black and white, sorry.
Yeah.
And then angles 3 and angles 5 are congruent. Have the same measure. All right. Theorem 3-2, corresponding angles theorem. Corresponding, remember we talked about corresponding? They're in the same position, same side. If you're in the bottom left, you're in the bottom left on the other side. So firstly, you have 2 parallel lines and a transversal. You don't have to write that down, that's given. Then corresponding angles are congruent. The theorem says corresponding angles congruent. Same measure. We'll type that out. Same measure. So if we're looking at who's got the same measure, we can say angle 1 is congruent to angle 5 because they're red on mine. But angle 1 and angle 5 are in the same. They're both top left. They're both corresponding angles and they're congruent. Angle 2 and angle 6 are top right. 2 and 6 are congruent. They have the same measure. And because supplementary angles, angle 3 is congruent to angle 7, they're bottom right, so they're congruent. Angle 4 and angle 8, bottom left, they have the same measure. All right, let's see how this looks, this information looks inside a proof. Now I put the proof down because you're going to be asked to use this proof to do another proof, and so we use it kind of as our building block, as our template. So a proof has a given, and usually the information given ends up where? It's usually the first statement, unless you have a whole bunch of stuff given, and then you'll put a little bit in the given and then grab it on the end. Is the last reasoning for a proof the word proof or proof? No, it's always something definitive. It's like a postulate or a definition or something for real. So let's look at this together, and all we're doing is we're looking at proofs are unfamiliar to us. So the more we see, the more familiar we get with the format and procedure. So in this statement, I would like a arrow, please, or a star. So the first thing we do is we put our given down. Angle L is parallel to M. That's given. So these two lines are parallel. The measure of angle 3 plus the measure of angle 4 is equal to 180. That's because they're supplementary angles. Could you say linear pair postulate? Absolutely. Linear pair postulate says two angles are supplementary. Supplementary says that they add up to 180. So the measure of angle 3 plus the measure of angle 6 is also 180 degrees because we know the same side interior angles postulate. Then we substitute out. If both of these guys are equal to 180, we substitute the 180 and put in angle 3 plus angle 6. And we can use the transitive property of equality to do that. I will also take substitution. That's also valid. Okay. Lastly, measure of angle 4 is equal to the measure of angle 6 because you subtract the measure of angle 3 from both sides. And that's a subtraction property of equality. And then we can say, when you have two angles that are of the same measure, what? There's a reason. We can say that they're congruent. So then we can say angle 4 is congruent to angle 6. Definition of congruence. Definition of congruence is when two items have the same measure, they are congruent. All right, so in problem number 2, we're given that A and B are parallel and that we want to prove 1 and 8 are supplementary. So the first thing we're going to do is write down our given. And then we're going to say angles 1 and angles 5 are congruent because if lines are parallel, then corresponding angles are congruent. And then we say the measure of angle 1 is equal to the measure of angle 5 because we know that's the definition of a congruence. Angle 5 and angle 8 are supplementary because 5 and 8 form a linear pair and they're supplementary. That means their measures add up to 180. And so I'm going to take out measure of angle 1. Sorry, measure of angle 5, and I'm going to put in measure of angle 1 because they're equal, and that's called substitution. So then I have angle 1 and angle 8 are supplementary because the definition of supplementary is they add up to 180. Okay, we're going to use this proof outline to make our own proof. So on your paper, write the word statements. And write reasons. It's like a little T diagram. All right, what is our first statement going to be? Given information. So we're going to say A is parallel to B, and that is because we were given that. Thank you for the gift. It's a gift that keeps on giving. So we are going to say, if we look, we're going to go ahead and just copy down 2 and 3 because we want to prove 1 and 5 are congruent. But the next thing we're going to do is we're not going to establish a relationship between 5 and 8. We're going to establish a relationship between 5 and 7. So let's go ahead and copy down 2 and 3. So angle 1 is congruent to angle 5. And that if lines are parallel, then corresponding angles are congruent. And then 3 says measure of angle 1 is equal to the measure of angle 5. And the reason is congruent angles have equal measures. What symbol can we use for the word equal? How about 2 lines sitting right on top of each other? Okay. Number 3. So, now we have to say that, now we're going to prove that the measure, no, we have to first say the angle because we're talking congruence. So we're going to say angle 5 is congruent to angle 7, and that is vertical angles. Let's go theorem. Okay, so angle 5 is congruent to angle 7, so that means the measure of angle 5 is equal to the measure of angle 7. Oops, I said 3. That's I learned how to count forward. That's the definition of congruence. Okay, almost there. What's the last thing we have to do?
No.
Let's substitute, right? We're going to take out angle 5. Oh, so we're going to take out measure of angle 5 and we're going to put measure of angle 1 because that's where we want to end up. We use the substitution. Substitution. Sorry, I was trying to solve stuff. And then we can say angle 1 is congruent to angle 7. That's the definition of congruence. All right. Boom. Alternate exterior angles theorem. What? Okay. So, of course, we have a transversal and 2 parallel lines. Don't write that down. Do write down that alternate exterior angles are congruent. They have the same measure. You know how I can remember all of these? Just look. If one of them looks small and the other one is a small one, then they're congruent. If one of them's big and the other one's small, then they're supplementary. I never had to remember these ones because it looks just like this. So in this case, angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. Easy. What are the measures of angle 3 and 4? Which theorem or postulate justifies each answer? So the measure of angle 3 is, so if we use P and Q as our parallel lines and M as our transversal, then 3 and this 105 are congruent by alternate interior angles. And then measure of angle 4, those are same side if we use angle L and M as parallel lines, and Q is our transversal. 4 and 105 are same side interior, so they are congruent. So I just subtract 180 from 105, and I know that angle 4 is 75. All right, so we're going to throw it down. We're going to go 1, 2, 5, 6, 7, 8. All the ones we don't have, we're going to put down, and we're going to justify reasons. So angle, we already have that angle 4 is 75. So now angle 1 is opposite, or, boo. Let's do angle 2 because he comes right from angle 4. Okay, just put it down. So angle 7 is 105, and that's vertical. 105. He's vertical. Angle 6 gets to be 105 because he's corresponding. Awesome. So we know angle 4 is 75. Could angle 6 be 105 because supplementary angles? Yes. Let's do angle 8. Has to be 105 because he's corresponding to 6. All right, so angle 2 has to be the other one. It has to be 75 because it's a linear pair. With angle 8. Great. Angle 1 has to be 105 because he's also a linear pair. I mean 75. This is going to say linear pair. Just getting squished. Angle 5 is congruent to angle 2 because corresponding angles are congruent. That goes to 5.